Mercury is the only metal that's a liquid at room temperature, and something that I've always wanted to do was to try making it solid. To do this, I just have to add some liquid nitrogen to a dish and wait for it all to cool down. Now, it looks like it's good to go, and I can pour in some of the mercury. This is a few minutes later, and it's definitely solid. I really have no idea what to do with it though, and I think it might be cool to just melt it again. So today, I'm going to be turning this dish into a silver mirror using some chemicals. To do this, I just need to add some water to a beaker and dissolve some silver nitrate. After that, I can pour in some ammonia solution, which causes some of the silver to separate out for just a second. The last ingredient is sodium hydroxide drain cleaner, and I need to wait for it all to dissolve. The solution's ready, but I only need 100 mils, so I'm gonna pour it into another beaker. To get the reaction started, I have to add some glucose, and I can now pour it onto the dish. It's already darkening because small particles of silver are separating out, and I just need to leave it like this for a while. This is 15 minutes later, and now when I pour off all the water and flip it over, there's a nice mirror on the back. This is ferrofluid. It's a liquid that's attracted to a magnet, and it likes to form a lot of small spikes. When I pull it away from the magnet, the spikes get bigger, but when I get too far from it, they completely disappear. Ferrofluid was first invented by NASA in 1963, and it's made by suspending super small particles of iron in a solvent. Here I have some gallium, and at room temperature, it's completely solid. However, it has a super low melting point of only about 30 C or 86 Fahrenheit. So, if I put it into a bowl of hot water, it should completely liquefy. It all eventually melted, and what I have now kind of looks like mercury. Unlike mercury though, it's not nearly as toxic, and it's much safer to hold in my hand. However, it is a lot messier, and it tends to stick to things and leave an annoying residue. This is a cube of aluminum. It's pretty light, and it barely weighs a pound. And this is a cube of tungsten, which is one of the densest metals. It's the exact same size as the aluminum one, but it's kind of crazy because this one weighs over 5 pounds. Its density is almost the same as gold, so a block of gold this size would weigh almost exactly the same amount. And this is a 42-pound tungsten cube. It has nice sharp edges. Oh god, you really, oh no. Oh. This is nitric acid, and it's one of the few acids that can react with copper. But oddly enough, it doesn't work well when the acid's pure. This is because of something called passivation, where a layer of oxidized copper forms and it covers the surface and protects the rest of the copper. To get it going, I have to add some water, which will dissolve the protective layer and let the acid attack it. This more dilute acid can completely shred the copper, and all the metal should eventually disappear. Today, I'm going to be showing you the classic barking dog experiment that I did a while ago on my main channel. To do this, I just have to fill a tall cylinder with nitrous oxide gas, which is the same thing that they use at the dentist. Then after that, I can add a few drops of a solvent called carbon disulfide. Now I just need to cover the top and shake it around a bit. I should now have a mixture of the nitrous and the carbon disulfide, and all I have to do is light it on fire. A couple weeks ago, I bought this online, and it looks like a generic piece of metal. However, it cost me close to $1,000, and if you held it, you'd immediately notice something weird. It feels abnormally heavy, and this is because it's osmium, which is the densest element. It's even denser than gold, and it's about twice as dense as lead. It's also extremely hard to find osmium in nature, and it's one of the rarest elements on Earth. What I have here is a chunk of indium, and I think it's pretty cool. This is because, even though it's a metal, it's extremely soft. To test this, I can just push on it with my nail, and it easily sinks in. The only metals that are softer than this are the alkali metals, like potassium and sodium, but those are extremely reactive. Indium, on the other hand, is pretty much inert, and it's non-toxic, so I should be able to try biting through it. That was so much harder than I thought. This is just a regular ice cube, and if I drop it into water, it floats. This is because as water freezes, it expands, and the density of the solid becomes less than the liquid. This, on the other hand, is another ice cube that I made, but this one's kind of special because it's actually able to sink. This isn't because of some weird ice cube making trick, though, and it's just because I made it using heavy water. This heavy water, which is also known as D2O, is about 11% denser than regular H2O. So, while it still expands when it freezes, this extra density allows it to still stay heavier than regular water, and I think that's pretty cool. A few months ago, I made some ice that was perfectly clear, and now I want to turn it into a perfect ball. To do this, I just have to put it on this large chunk of aluminum, and it almost immediately starts melting. Then on top of this, I can slide on the other half, and now I just have to wait. Over the next several minutes, the ice slowly melted, and the two parts eventually sealed together. At this point, it should have been done, and when I opened it up, I had a nearly perfect ball of ice. There were, of course, some small imperfections, but it was still way nicer than I expected. It was super clear, and even though it was just ice, I felt like it was one of my favorite things I've ever made. Within just a few minutes, though, it was already melting, and like everything else in life, all good things must come to an end. Today, I'm going to be doing one of the weirdest chemical reactions I've ever seen. To get started with this, I'll get a dish, and I'll add a mixture of sulfuric acid and sodium bromate, followed by a solution of malonic acid and water. Then into this, I'll shoot in a solution of water and sodium bromide, and it almost immediately turns yellow. This is just a bit of bromine forming, and I'll have to mix it around and wait for it to disappear. Now I can add the final ingredient, which is some ferroin indicator. I also have to mix this around until it looks pretty even, and after that, I just have to wait. At first, not very much was happening, but then I started seeing some small little spots appearing. Even more of them then started popping up, and they were all getting bigger and bigger. What's going on here is called a Belousov-Zhabotinsky reaction, and it's still one of the weirdest reactions I've ever seen. A while ago, I made some bubbles filled with propane, and they were pretty fun to light on fire. What I've been really wanting to try, though, is to do it with hydrogen. This is because, unlike the propane, it's actually kind of explosive, and I think it could be a lot more exciting. But anyway, to try this, I'll first need to make some bubbles, so I'll get some soapy water, and I'll shoot in the hydrogen. At this point, I felt that it was looking pretty good, and I carefully scooped out some of the bubbles. Now, all I need to do is light it on fire, and I think it's a lot more fun than the propane. A few weeks ago, I made some bubbles that I'd filled with hydrogen gas, and I thought it was pretty cool. Since then, though, I've built up a bit of courage, and I think I'm ready to try with this. Like before, this balloon is still filled with mostly hydrogen. However, this time, about 1/3 of it is oxygen. This new mixture is actually explosive, and I'm just going to shoot it into some soapy water. Eventually, I'm left with a nice pile of scary bubbles, and I can very carefully scoop them out. Now, with some good hearing protection on, so I don't destroy my ears, I guess I can just try lighting them on fire. Holy! What I have here is something called ferrofluid, and if I put a magnet under it, it's able to make these really weird spikes. Then, if the magnet's pulled away, the spikes all magically disappear, and this honestly kind of blows my mind every time I see it. What I also think is interesting, though, is what happens if I put it directly onto the magnet. It doesn't really spike like before, but it becomes super slippery. It's actually able to hold itself up, sitting on top of the ferrofluid, and it glides around with what feels like no friction. Personally, though, my favorite thing is what it can do on paper. It's able to slide super effortlessly, and it feels like the smoothest marker I've ever used. The line that it makes is also shockingly clean, and I just think it's pretty cool. What I have here is just a regular ball bearing, and when I drop it onto some metal, it kind of doesn't do anything. However, when I drop it onto this thing that I made, which is called an atomic trampoline, it just keeps on bouncing, almost like it's never gonna stop, and I think this is pretty cool. What I've been really wanting to do, though, is to take 2 of the trampolines that I made, and to see if anything weird would happen if I tried bouncing the ball between them. And it was honestly even better than I expected. I mean, I assumed that it would bounce a lot, but not nearly this much, and the super high-pitched sound that it makes tells me that it's bouncing a ridiculous number of times. In fact, at its peak, at least based on what I could count, I could sometimes get it to bounce up to several thousand times per second, which in my opinion is kind of unbelievable. A few weeks ago, I bought some titanium tetrachloride, which I heard is one of the most obnoxious chemicals. It came in this nice elongated tuna can, and it was wrapped up in a little blanket. When it was just sitting in a bottle like this, it wasn't too scary, but it still took a little while to get the courage to open it. So now, I finally feel ready to crack it open, and I for sure have to do it in my fume hood. Almost immediately, a bunch of white smoke started pouring out. This is a mixture of hydrochloric acid and titanium oxides, which form as the titanium tetrachloride reacts with oxygen and moisture in the air. If I open this outside my fume hood, it would easily fill the room with a haze, and it also wouldn't be very healthy to breathe. But anyway, what I've always wanted to do was try and soak a super ball in it. So I dropped in one that I got from the dollar store, and I let it sit for a couple minutes. When it was done, it had completely changed colors, and it kind of looked like a little planet. I don't know for sure, but this has to be the world's smokiest ball. For this video, I'm going to try turning this penny into gold, which is something that I've always wanted to do. The first step is to clean the penny, and all I need is some vinegar and some salt. As it sits there, the oxides are getting slowly removed, and while I wait for that to happen, I'll get something else ready. For this mixture, I'll start with some water, and I need to dissolve some sodium hydroxide drain cleaner. When this is all gone, I just have to dump in some zinc metal and turn on the hot plate, and that's basically it. Now, coming back to the penny, it's looking pretty good, and I'll just quickly wash it off and drop it into the zinc mixture. As it sits there, the penny is slowly getting coated with zinc metal. It's now been about 20 minutes, and it looks like it's been completely covered. What I have now is a completely silver penny, which I think is pretty cool. I still think gold is better though, so I dropped it onto a hot plate and cranked up the heat. As it warms up, it slowly changes color, and eventually, it's completely gold. Unfortunately though, even if it really looks like it isn't real gold. It's actually brass, and it formed because the heat caused the zinc coating to combine with the copper in the penny. Just for fun, I decided to make a whole bunch more, but I have no idea what to do with them. A few years ago, I was able to make something called hot ice, which would instantly freeze when it was poured out, and I was able to grow this weird tower thing. What I didn't show in that video, though, was that it could also crystallize when something was placed into it, which I thought was really cool, and since then, I've been wanting to scale it up. Specifically, this is because I really wanted to be able to put my entire hand into it, and, well, I've finally decided to try this. So, I quickly whipped together an extremely large batch of the hot ice, which is just a concentrated solution of something called sodium acetate, and when it was ready, I was honestly a bit nervous. This is because as the sodium acetate crystallizes, it will release a lot of heat, and I was kind of worried that this could burn my hand. Despite that though, I just went for it, and immediately a bunch of crystals started forming on my fingers, and I could feel everything quickly getting hotter and hotter. However, thankfully, it stopped heating up just before it started hurting, and eventually, my entire hand was fully encased in a huge block of hot sodium acetate, which honestly felt kind of nice. What was also really nice was that my hand was actually relatively easy to take out, and what I think is really cool is that with just a bit of heating, this entire solution can be regenerated. I can then put my hand in again, and I can do this over and over, and in my opinion, what makes this even more fun is that it seems to be different every time. A few months ago, I bought a dry ice maker, which was pretty much just a denim sock strapped to a CO2 tank. After running it, I loosened it up a bit, and I was left with some nice and powdered dry ice. I really wanted a nice block of it though, so I bought a different tool thing to make it. It looks a lot more complicated than a fancy sock, but it also doesn't seem too crazy. I think that all I have to do is connect it to a CO2 tank. I quickly skimmed the instructions, and the only warning was to keep the pressure really low. So, I guess I'll just go ahead and try it out. As the CO2 leaves the tank, it's a liquid, but when it enters the plastic thing, it's all becoming a solid. Now, apparently all I have to do is wait for the whole thing to fill up. When it started spraying out the side, I figured it was done, and I closed the tank. The next step is to carefully remove the strap thing and open it up, and I have a nice cylinder of dry ice. It isn't perfect though, and it's a lot more fragile than I thought it would be. Either way, I don't need the whole chunk of it, and I only need about half.